Thank you all for joining Friends of a Clean Hudson for our webinar presentation this evening. This is a webinar. You will not have access to your microphone or your video camera, but please feel free to put your questions in the Q&A. We will save them for the end of the presentation and have an opportunity to review them as a panel. So I will hand over the microphone to Pete Lopez to get us started.
Thank you, Drew, and good evening, everyone. And folks, thank you for giving up your time to join us on this very important issue. So all of us are dedicated to ensuring that the Hudson River cleanup is successful and that the remedy is ultimately protective of public health and the environment. Just in terms of my role, I serve as the Executive Director of Policy, Advocacy, and Science with Scenic Hudson. And just recently before that, I was the Region 2 Administrator overseeing EPA Superfund engagement on this issue and was present during the second five-year review, EPA's five-year review. So today we're focusing on EPA's draft third five-year review and its impacts to the Hudson River. And today we have an incredible array of very talented and dedicated, knowledgeable individuals who will be presenting. Our goal is to work through our findings, give you some background, and then open it up for questions to give more clarity on this issue. So with us today, this evening, you'll hear from Jen Benson, who's the Environmental Action Director for Hudson River Sloop Clearwater, Drew Gamels, our Senior Attorney at Riverkeeper, Althea Malarkey, who's the PCB Project Consultant for Scenic Hudson, Kevin Farrar, an independent scientist and retired New York State DEC geologist, and also Jay Fields, independent scientist and retired NOAA environmental scientist. So again, a very capable, knowledgeable group. And with that, we'll move to the next slide. I'm just going to give you a quick run through of our presentation and then turn it over to our experts. So as you see on the screen, history of the Hudson Superfund engagement, Hudson River PCBs, status of the cleanup and the five-year review, PCB concentrations in fish and sediment, key to this conversation, and then policy program and technical concerns that we have identified in EPA's current draft five-year review, and then upcoming actions, and then ultimately we'll go to question and answer. So with that said, I'll turn it over to my colleagues and move to the next slide. Jen, are you doing site?
Yes, I am. As usual, I'm struggling to turn my mute off after 4 years of living in a Zoom world here.
Thank you, my friend.
Thank you so much, Pete. So I'm just going to run us through a little bit of the timeline. Everyone can read the slides themselves, but the contamination entered the Hudson River from two General Electric facilities in Fort Edward and Hudson Falls, millions and millions of pounds between 1947 and 1977. And in 1984, the EPA designated a 200-mile stretch of the Hudson River as a federal Superfund site. So it is a federal Superfund site from, we'll see a map in a minute, from those plants all the way down to where the Hudson River hits the Atlantic Ocean in New York Harbor. And so that entire stretch of the river is affected by PCB contamination. In 2002, the EPA adopted a cleanup plan, which is known as the Record of Decision, which is meant to address the PCB contaminated sediments in the upper Hudson River, so that 40-mile stretch above the Troy Dam. And from 2009 to 2015, General Electric dredged targeted areas in the upper Hudson River. And in 2019, EPA issued a certificate of completion of the remedial action. So there was a lot of things that have happened in between, but just to kind of set a little bit of context for everyone as we move into the rest of the presentation, these are some of the major points of the site history. All right, so given that the five-year review is focused on the the upper, what we call operating units of the upper Hudson River. This is the map of the area that is being reviewed for the cleanup efficacy within the 5-year review. So despite only seeing this much of the map, what we know is that what happens in the upper river has a huge impact on the remainder of the river as well. And so for the broader Superfund site, what happens in this upper 40-mile stretch has a huge impact on the remainder of the 200-mile Hudson River PCB Superfund site, which includes communities in 14 New York counties and two New Jersey counties. And so the way that we look at Superfund is a site is then broken up into operating units to be able to better tailor remedial action and be able to also just break huge geographies into more what I would consider accessible chunks. There's probably a more appropriate terminology for that. And so we see operating unit 1 and we see operating unit 2. So operating unit 1 is known as the remnant deposits, and then operating unit 2 is where the record of decision dredging was in the upper Hudson River. We see operating unit 3, 4, and 5. And so does anyone else have a remark on that slide? I can't see my little chat function. Sometimes we jump in. No? All right. So we can flip to the next slide. So the cleanup agreement. So the record of decision established essentially a 2-part plan, which was signed in 2002 with a 6-year targeted sediment dredging in the upper Hudson River, which was meant to rapidly reduce risks, followed by a period of natural recovery. So a tight timeline for action with then a longer timeline for natural recovery. And so this was really called for because it was meant to get a rapid decrease in PCB concentrations. The record of decision also included institutional controls in the form of fish consumption advisories, which you'll see on the right side of your screen, as well as fishing restrictions, which are meant to stay in place until the relevant remedial goals are met. And so these controls are really designed to prevent or limit exposure to PCBs through the consumption of contaminated fish. And there are some really challenging things with that. It's hard to rely on people, and that really puts the onus of preventing exposure on individuals. And we really want to make sure that the burden doesn't rest on our communities. So as you think about these fish consumption advisories, also just take a look at how complex they are. The rules really vary drastically as you move south through the Hudson River. And so it takes a lot of working knowledge to not only be able to identify the fish that you catch, but also know where it is safe to consume fish and in what quantities, and not only in what quantities, but for whom. And then the other side of it, the monitored natural recovery is really a risk reduction approach that uses ongoing naturally occurring processes to contain, destroy, or reduce the availability or toxicity of the contaminants in the environment to living organisms. And so monitoring of the ecosystems during monitored natural recovery is really meant to ensure that the conditions needed for the monitored natural recovery are occurring and progressing towards the cleanup goals. And so the primary MNR, as we call it, processes that occur in the Hudson River include cleaner sediment entering the river from upstream and tributaries, sediment movement and burial, and PCBs binding to organic matter and making them less bioavailable.
Awesome. Thank you, Jen. So I'm going to take over and talk a little bit about the cleanup goals. So Jen talked about what the cleanup plan was, that two-part cleanup plan for the dredging, and then phase 2, which is the monitored natural recovery. And then part of that original cleanup plan, the 2002 record of decision, included some key cleanup goals, remedial action objectives as they're known. And so these remedial action objectives, there were 5 of them, and they focused on the media. They established kind of key PCB concentration targets for each media type. So there's target for water, for sediment, and for fish concentrations. And so within those remedial action objectives, which were the long-term goals of what EPA hoped to see from the remedy they selected, EPA also established some interim remediation targets. And so one key interim remediation target that we really are focused on pertains to the goal of reducing the cancer risks and non-cancer health hazards for people eating the fish. And so one of those interim targets, or the first interim target we should have hit, was 0.4 milligrams per kilograms of PCBs in fish fillet. And EPA targeted that this goal would be achieved 5 years from the completion of dredging. So as Jen mentioned in the timeline, dredging was completed in 2015, so this goal should have been achieved by 2020. Well, 2020 has come and gone, and as you'll see in our data analysis and EPA's own data analysis, we have not hit this target. And this target was key because it represented a safe level for an average angler to consume a half-pound fish meal every 2 months. The second interim target that EPA anticipated to be achieved is a 0.2 milligram per kilogram PCBs in fish fillet, which they expected to achieve 16 years from the completion of dredging. So that's 2031. That represents a safe level of consumption for an average angler of a half-pound fish meal every month. And so that signifies the ability to start loosening some of those institutional controls that are in the form of fish consumption advisories. But since we're not hitting these interim targets, those fish consumption advisories remain more important than ever. EPA also expected a post-dredging recovery of 7 to 9% in surface sediment and fish. And as you'll see in our data analysis, we are not seeing a decline in surface sediment and fish at those levels. It's actually much less. And that's really a concern because it extends the time that we're going to see, or that is going to be required to achieve those ultimate remedial action objectives, those key targets that represent safe PCB concentrations for both humans and the environment. So we keep talking about 5-year reviews and what they are, and I'm sure a lot of you have attended some of our previous programs where we talk about this, but just as a refresher, every 5 years, EPA is required to review the Superfund site, these federal Superfund sites, and they're required to evaluate whether the remedy is functioning as intended and whether it is protective of human health and the environment. And part of that review requires EPA to look at 3 key questions. And you'll see these in the third draft 5-year review, or they're in every 5-year review. So question A, is the remedy functioning as intended by the decision documents? Question B, are the exposure assumptions, toxicity data, cleanup levels, and remedial action objectives used at the time of the remedy selection still valid? And question C, has any other information come to light that could call into question the protectiveness of the remedy? So for the Hudson River Superfund site, the first 5-year review was done in 2012, where EPA looked at these 3 questions, and they, at that time, believed that the remedy would be protective of human health and the environment. Now, in 2012, GE was still dredging, so everyone was optimistic, believed that the dredging would achieve those targets that EPA established. Fast forward 5 years after that, in 2019, when EPA finalized the second 5-year review. Again, they looked at these 3 questions and they determined that they could not make a decision. They said at that time there was not enough data to render a decision on whether the remedy was functioning as intended and whether it was protective of human health and the environment, and said they needed more information in order to make that decision. Now here we are, 2024, looking at these questions again. And the Friends of a Clean Hudson have worked with our independent experts to look at the publicly available data and assess these questions on our own. And based on our analysis, we believe the determination that EPA has to make is a not protective determination, that they have enough data and that really, the remedy is not functioning as intended, that the exposure assumptions, toxicity data, cleanup levels, and remedial action objectives used at the time are not valid, that there are questions that need to be reviewed, and that there's more information that has come to light that really indicates that PCBs are more dangerous than thought back in 2002 when EPA made this when EPA selected the remedy and selected the remedial action objectives. So here we are. It is third 5-year review time. We've really been anticipating it, so we're glad to see that it's finally out. It was dropped on July 10th. It is available for a 90-day public comment period, which is why this webinar is so critical. We want to make sure that the public has enough information to participate and to comment and to go to EPA's webinars informed and ready to ask questions. For this third 5-year review, EPA evaluated data collected since the last 5-year review. So that includes data from 2017 to 2021. EPA also includes some fish data collected from 2022 as well. Now, in this third 5-year review, EPA concludes that human health and ecological remedial goals have not been achieved. They acknowledge that. And they say that progress is being made toward the remedial action objectives presented in the record of decision, and based on analyses presented in this 5-year review, at least 8 more years of data, or at least 2 more years of data beyond the current post-dredging data set are needed before a meaningful time trend in PCB concentrations for water column and fish data can be determined. And so EPA is once again deferring rendering a protectiveness decision, saying that they need more data to evaluate these trends and to figure out why there are some uneven patterns in the fish recovery and why things aren't as projected. And so EPA is rendering, a deferred protectiveness decision, but they are saying that they would do an addendum in 2025, or maybe it'll come out in 2076, but definitely by 2027. They said that they will issue a determination. And so we are here to present our analysis. What are independent experts seeing in the data that makes it a concern to us? And so I'll hand it off to Kevin Farrar to dive into that.
Hello, folks. Nice picture of a pumpkin seed, by the way, Drew. I like that one. Can you go to the next slide, please? Okay, so I'm going to talk to you a little bit about the fish data that we're looking at. We've done extensive analysis. We're just going to show you a little bit of it today. This graph shows the PCB concentrations in fish in the Upper Hudson. EPA has developed a weighted average metric that averages 3 sport species, bass, bullhead, and perch, and average it over the length of the Upper Hudson. So it's a composite, an average fish concentration, if you will, in the Upper Hudson. You can see the blue dots on the left of the graph are from before dredging, the orange is during the dredging, and the green is after dredging. And that's what we're focusing on, is the performance of the monitored natural recovery after dredging. But I want to point out a couple things about this graph. You see a black box on there. You have to be cautious with those 5 years of data because they were gathered and analyzed using a sample preparation methodology that understated the amount of PCB in the sample. So they're probably low by 50%, 75%, something like that. So when you look at that blue pre-dredging data, there wasn't a significant natural recovery going on before dredging. That's an artifact of the analytical issue we had. But if you look during dredging, there was a modest increase in PCB concentrations during dredging. Then the dredging stopped in 2015. And the green data you see, it goes from 1.1 down to, what is the most recent one, 0.58. And there's a wet weight. It's just if you fillet the fish, run it through the analysis, that's how much PCB is in the animal. This is the progress toward, I believe, that EPA is referring to in their draft 5-year review report. But there's an issue with this analysis. If you could go to the next slide, please. So one of the things about PCB, it's an interesting chemical. It bioaccumulates in the animals, in the food web. And the reason it does that is because it preferentially absorbs to fats. It's called lipophilic. So what that means is if you have two of the same species of fish in the same exposure conditions, a fish that has twice as much fat will have twice as much PCB in it. So the amount of PCB is directly linked to how much fat's in the animal. So if you simply divide the concentration that you found, those green dots on the previous graph, by the percent lipid, then you can say, okay, here's how much PCB there is per percent lipid. And this takes lipid out of the equation when you're looking at things from year to year. So when you look at the lipid-based data for this composite metric, the average sport fish, it looks like it really isn't changing much in the years since dredging. And the reason that is, while the wet weight graph shows it going down, but the lipid doesn't, is because the amount of fat in the animals, the amount of fat in the fish, has been declining over time. So that apparent decline you saw on the previous graph is actually due to the fish getting skinnier, not to the fact that there's been a change in exposure conditions. When taking the amount of fat out of the equation and just looking at it on a lipid basis, it appears that there really isn't much changing in the sport fish of the Upper Hudson in the years post-dredging. Next slide, please. So another data set they look at, EPA has GE not only collect large sport fish, the bass and the bullhead and the perch, they also gather pumpkin seed and some minnow species. And the minnow data is a little spotty, which species they get in which years and where. But however, we have a very good record for pumpkin seed. And these pumpkin seed are collected at a very small size. They're probably only 1 or 2 years old. So they're pretty good at showing rapid changes over time. And they also provide information as to what the food base is for the larger sport fish. So the pumpkin seed represent what the bass and the bullhead and the perch are eating. So if you look, there's 4 graphs here, and they're geographically 4 different parts of the river. Reach 8, River Section 1, is the first 6 miles from Fort Everett down to the Thompson Island Dam. The next 2 is what the EPA calls River Section 2. It's the next 2 short pools as you're going down the river. And then the last one is from the Northumberland Dam, just above Schuylerville, all the way down to the federal dam at Troy. These data represent that. So if you look at the pumpkin seed here, starting in 2016 for each graph and ending in 2021 for each graph, there is clearly no evidence of significant declines in PCB concentrations. It goes up and down, up and down. Now, the red is total PCB, that wet weight number. The blue is lipid basis. We looked at it on a lipid basis also. And because the lipid in the pumpkin seed isn't changing, the pattern is the same between the blue and the red. And the overall pattern here is, over time, no matter which portion of the river we look at, does not appear to be much decline in the amount of PCB that's in the pumpkin seed. In other words, the amount of PCB that's in the little fish that the big fish are eating. Next slide, please. So this is another way to look at the pumpkin seed data. Again, we have these 4 geographic areas going from upstream to down. Only in this case, the data are broken up by pre-dredging, which is the left-hand in each one graph, the left-hand set of columns. Second one is during the dredging. And then the last 2 are the first 3 years, and then the next 3 years after dredging was over. And you can see that it appears that there was an increase in PCB and pumpkin seed during dredging a little bit, which is not surprising. And you also see that when the dredging stops, the PCB and the pumpkin seed in all cases is a little bit lower than it was before. So there absolutely was a drop in pumpkin seed concentration associated with the dredging. But what we're paying attention to now is, how is the natural recovery, that post-dredging natural recovery, going? That's the phase of the remedy they're in. That's what's going to drive when we meet our targets. And if you look at in each of the 4 graphs, if you look at the last 2 sets of columns, you do not see a decline. And reach 7, for example, you see a pretty significant increase. So again, we're looking at this from the point of view, is the remedy performing as it was designed? And the answer is no, we're not seeing a significant decline. And the big fish aren't, if you look at a lipid basis, aren't going down, and the little fish aren't going down. So now I'm going to turn it over to Jay, and he can explain to you what's going on with the sediment.
Next slide, please. The first slide is the figure 2-9 in EPA's 5-year review, showing a river-wide area-weighted average by river section in the 3 river sections. And the post-dredging sampling in the orange are dots and are the 2016 sampling conducted by EPA and GE, and the 2017 study collected by New York State. They're considered as one complete study, and the 2021 sampling in blue. And the average adjusted total PCBs as calculated by EPA in the top 2 inches of the surface. EPA collected the top 2 inches of surface sediment in order to track changes in PCB concentrations over time. They would show the fastest change. It's also important to note that the top 12 inches of surface sediment was considered the bioavailable layer and the basis for the target cleanup levels in the rod. And what we see in this figure is that the concentrations are particularly high in river sections 1 and 2 and don't show much, if any, evidence of decline. Next slide, please. So this is pretty much the same similar figure showing average total PCBs as the laboratory reported them in the top 2 inches of surface sediment by river section and comparing the 2 years. And the same conclusions can be made that the concentrations don't show much evidence of decline. Next slide, please. This slide shows the data for the areas outside the dredged areas and within the dredged areas by river section. So on the y-axis now we're looking at tri-plus PCBs, PCB congeners with PCB congeners with 3 or more chlorines, which EPA has used to represent the PCBs most likely to accumulate in fish. And outside the dredged areas show a similar pattern to what we saw with the total area in the graphs in the previous slide, and highly elevated concentrations in river section 1 and 2. Within the dredge area, what we note is the marked increase in river section 2, which is clear evidence of recontamination of the dredged areas. Because the surface cleanup levels for river section 2 and river section 3 in the top 12 inches were approximately 3 times higher than river section 1, highly elevated PCBs remained in the surface of those river sections after dredging. And these remaining PCBs in the surface in river section 2 are the most likely source of this recontamination. Next slide, please. This slide compares the data collected in 2021 with EPA's model projection of tri-plus PCBs in the sediment top 2 inches, assuming 8% natural recovery decay 6 years post-dredging. And in all 3 river sections, the PCB concentrations greatly exceed the model projection 6 years post-dredging. An important thing to keep in mind is that all of the estimated recovery in fish PCBs was based on a comparable recovery in surface sediment PCBs. If the sediment is not showing a clear evidence of decline in PCBs over time, fish PCBs would not be expected to decline at a faster rate. And that's all I have, and I'll turn it over to the next speaker.
Hello, everyone. So I'm going to talk about some of the policy and program concerns that we have with this third 5-year review. And one of the first things I want to talk about is, while we're grateful that EPA is acknowledging what this 5-year review and what we feel the second 5-year review even showed, is that there are problems with the cleanup. There's been sort of a red flag has been flying for quite some time. We feel that there's been scientists from the federal agencies and from New York State who actually tried to sue EPA back in 2017 on the basis of feeling that they were not looking at the data correctly. The 1 year and 3 year promise that's in this 5-year review from EPA is great. At least they are acknowledging that the interim goals that they had expected to see by 2020, they're not seeing. That there are some problems with the sediment and the fish that they don't understand. That's great. We feel though that they actually do have enough data to actually answer those 3 questions. And if you answered the 3 questions that Drew spoke about earlier, the only option would be a not protected determination. We also feel this 5-year review does, in essence, ignores the time frame goals. I know that you heard Jen and Drew both say rapidly reduce the health risks. That was sort of the point of this remedy that was selected back in 2002, is to reduce the risks in a certain time frame, which is what the 2020 and the 2032 goals were about. EPA is supposed to measure the success of the cleanup by a certain time frame to know if they were on track. The ROD does not say progress towards the goals. The ROD says these are the goals. And by failing to do this, we feel that EPA, it's a fundamental purpose of Superfund is to protect public health. And by putting this fish consumption advisories as the only means of protecting people from exposure to eating fish, that they are not addressing the legacy pollution that has been affecting communities disproportionately for decades. Basically, as you heard Jen say, they're placing the burden of protection from PCB contamination on the people themselves rather than on the polluter, in this case, General Electric. Next slide. You've heard both Kevin and Jay talk about there's certain key flaws in EPA's technical analysis. And I just want to, in case we haven't mentioned it, and if you haven't had a chance to look at the technical report that EPA put out, it's pretty dense and we are still digesting it, and we will be issuing our own public comments, and we'll be welcoming asking people to invite us, and we'll tell you more about what we're seeing in the technical analysis as we have more time to digest it. But one of the first things that we wanted to talk about is that they did something we were not expecting. They took the pre-dredging data and they compared it to the post-dredging data to say that progress is being made towards the cleanup goals. That's actually not what the 5-year review is supposed to be about. It is supposed to be about measuring the success of what the remedial action did compared to what ROD said it was going to do. So we feel this is a little disingenuous of EPA to put this in here because it looks like there's something, really remarkable that's happened. And we did not do that, and we're not going to do that in our technical comments, but we wanted to make sure that we put a note in there just to show why EPA did that. We also are a little concerned that protecting public health and the environment is about the rapid risk reductions in this particular remedy and the monitored natural recovery rates. Even EPA acknowledged they don't think they're going to be at 7 to 9% as the ROD. They're hoping that the cleanup, the new monitoring that they're going to do in the next year or in the next 3 years, they're going to try to understand it better. And that for us, what that means is you already understand that monitored natural recovery, the sediment and the fish are recovering probably closer to 3 to 5%, which is not going to get you to the goals that were laid out. You know that already. Waiting 1 year or waiting even 3 more years is not going to give you any more, a different answer. Next slide. And because that monitored natural recovery is not performing as anticipated, human health and the ecological risks are well above the risk range, which bottom line, that is why we have the Hudson River Superfund site. The acceptable risk range for people, especially in the Hudson River Valley and the lower Hudson Valley, for communities of color who are big fishing families, and especially since 2020, we're seeing an uptick in people who are feeding fish to their families. That's well above EPA's acceptable risk range. The dredging was done to reduce those risks in a rapid time frame, and that monitored natural recovery would happen more rapidly than what it's doing. put this sign over here. This is called Cut the Fat to Cut PCBs. And these are actually magnets that are handed out by Department of Health to try to reach people, to make them understand that if you're going to eat fish from the Hudson River, you have to cut the poison first. And this is great, but this should not be what a Superfund cleanup is about. Protect yourself and cut the poison out of the fish is not what New York State agreed to in the 2002 record decision. And we'd also like to point out that ecological receptors, the sport fish, the mink, the ducks, the other critters that live in the Hudson River, they can't read the warning signs, and they don't cut the fat, they don't cut the poison out of the fish before they eat it. So fish consumption advisories as an institutional control does nothing for ecological risks. We believe placing the burden on the public to regulate their own behavior to avoid the risks caused by PCBs is unfair, it's unjust. And we also believe that EPA needs to update its understanding of the toxicity of PCBs. I believe both Jen and Drew have mentioned this. Since 2002, when EPA first had record decision, since 1984, there has been a lot of new research and understanding on how toxic PCBs are at much lower levels. But yet EPA is making health risk-based decisions for the Hudson River based on that outdated information. And we would like to see, and we know that EPA itself on the national scale have looked at this. They've been looking at it since 2012. It's been, over 12 years since they started doing this. We believe they need to update the toxicity understanding. If you're going to review and make decisions, it should be on the very best available data that you can. Next slide. So Jen, this is for you.
Oh, thank you, Althea. Well, we've come to the end of our formal presentation, but before we transition to Q&A, we just wanted to share some actions and next steps. So you've seen a robust participation. You've seen a robust presentation from us tonight. In our follow-up email, we will be linking to the independent review that we released last year, the June addendum, as well as the full draft 5-year review from EPA. And so a great way to engage with this process is to submit public comments on the draft third 5-year review. So we have the email up on the screen. We'll also email it out to everyone who's participating tonight. The public comment period is open through October 8th. Another opportunity is to contact your state and federal representatives and urge them to speak up. We have a lot of champions, both at the state and federal level, who have been working alongside Friends of the Clean Hudson for years in some cases on this issue, but it means a lot for our elected representatives to hear from their constituents. So it's great to reach out to the office, see where they stand. You can share the recording of this presentation, which you'll be getting in email up through the end of the presentation before the Q&A starts. So please urge them to speak up. And if they're already doing so, give them a robust thank you as well. Another way is to urge your community and your county or your county to adopt a resolution to protect the future of the Hudson. We also have a mailing list, so you can
Oh no, Jen, you muted yourself at the best part, the mailing list.
Wow, my tech abilities are so low today. My apologies, everyone. We have an email list that we send out critical and timely updates about Hudson River PCB. So if you're not on the email list, definitely join us on there. And then also EPA is having a virtual meeting on Wednesday, August 21st, which is next week. And so I can put that link in the chat as we transition into the Q&A. So please use the Q&A feature on your little bar. It might be at the top, it might be at the bottom, but just click Q&A and you can type your questions in, and then our panel of experts will do our best to answer them in the time that we have remaining today.
And here are our email addresses for myself, Jen, and Althea. You can always reach out to us with any additional questions as well. We are available, but in the meantime, we're here and we'll take some questions.